In this session, we will discuss about two-port network parameters. See, we have discussed the topic two-port network in the previous videos. A port is defined as any pair of terminals into which energy is supplied or from which energy is withdrawn or where the network variables may be measured. That is a port. See, in this figure we can see this represents a pair of terminals. So this acts as a port. So here, in this case, we are discussing about a two-port network. So a two-port network has only two pair of accessible terminals. Usually one pair represents the input and the other pair represents the output. So this pair represents the input and this pair represents the output. So this represents a two-port network, and here the variables are marked as V1 is the input voltage, I1 is the input current, P2 is the output voltage, and I2 is the output current. See here, suppose if we are giving input to this, then it will act as an input terminal. If we are taking output from this terminal, then it will act as an output terminal. That is why I am saying it is an output voltage and output current. Okay. So in the figure, 1 dash and 2 dash are ports. Here it is numbered as 1 dash, it is numbered as 2 dash. So 1 dash and 2 dash are ports, and the two ports containing no sources in their branches are called passive ports. And if the two ports have sources in their branches, then they are called active ports. So based on the sources, the ports are classified as passive and active ports. If there is a source, then the port is an active port. If there is no sources, then the port acts as passive ports. And the variables of the two-port networks are V1, V2, I1 and I2. See, now we are going to discuss about the parameters of the two-port network. There are different parameters such as impedance parameter, admittance parameter, transmission parameters and hybrid parameters. First we will discuss about, in this session we will discuss about the impedance parameter or set parameter. Here we are going to discuss about the impedance parameter, and that impedance parameter is obtained by open circuiting the terminals. So that is why it is called open circuit impedance parameter. So we will now study about the set parameter. Okay. So let us see. The set parameters for a two-port for the positive directions of voltages and currents may be defined by expressing the port voltages V1 and V2 in terms of the currents I1 and I2. So here we have a two-port network. For getting the impedance parameter, we will represent this V1 in terms of I1 and I2. Similarly, V2 also we will represent in terms of I1 and I2. So that is saying that the set parameters for a two-port network for the positive directions of voltages and currents may be defined by expressing the port voltages V1 and V2 in terms of the currents I1 and I2. Here V1 and V2 are dependent variables. That means they are depending on the values of other values such as I1 and I2. And here I1 and I2 are independent variables. That means the values of I1 and I2 does not depend on any other quantities. So we will represent V1 in terms of I1 and I2. So V1 is a dependent variable and I1 and I2 are independent variables. Similarly, here V2 is dependent on the value of I1 and I2. So V2 is a dependent variable and I1 and I2 are independent variable. The voltages at port 1 dash is the response produced by the two currents I1 and I2. See, here we are representing voltage in terms of two currents. So we can say that the voltage at the port 1 dash, that is V1, is the response produced by the two currents I1 and I2. So we can write the port equations as V1 equal to Z11 I1 plus Z12 I2. Similarly, V2 equal to Z21 I1 plus Z22 I2. So here V1, V2, we know that these are the port voltages. I1 and I2 are port voltages, port currents. Okay. And here Z11, Z12 is the parameter relating to the port 1. That is a set parameter relating to the port 1. And Z21 and Z22 are the set parameter relating to the port 2. So we can represent this equation in terms of matrix form. So we can represent the equation as a matrix voltage V equal to matrix Z into current matrix I. Here Z matrix contains variables Z11, Z12, Z21 and Z22, and these represents the network functions and are called impedance parameters. So we can write it. We know that in the equation we are representing this matrix from this equation. So first matrix is V1 and V2. It is a column matrix, and second matrix is impedance matrix. So it is also another matrix, 2 by 2 order matrix, that is Z11, Z12, Z21, Z22 are the entries in that matrix. So first row contains Z11 and Z12, second row contains Z21 and Z22. Similarly, third matrix is I1, I2 matrix, that is also a column matrix. So we can write Z matrix in this form, voltage matrix or V matrix in this form, and current matrix in this form. So the equation will become V1, V2 equal to Z11, Z12, Z21, Z22, I1, I2. So this is an important equation, and here these quantities represents the open circuit set parameters or impedance parameters. So the individual set parameter is obtained by setting the port currents equal to 0. So here different parameters Z11, Z12, Z21 and Z22. We want to find out this individual parameter, set parameter. For getting that parameter, we are setting the current to 0. Okay. Let us see the details. Suppose we are having a network like this. See, if we have this network, and here we are setting the port, that is 22- port, and the current through that 22- port is I2, and we are setting that I2 equal to 0. Okay, so let us go to the equation, this equation. When what will happen to this? Whenever I2 will become equal to 0, I2 equal to 0, this quantity will not be there. So we can find out Z11. Okay, so when I2 equal to 0, then Z11 will be equal to V1 by I1, right? So we can write, when I2 equal to 0, that means the port 22- is open circuited. In that case, Z11 will become V1 by I1, and that is at the point I2 will be equal to 0. So we can say that this Z11 is the driving point impedance. You know that this V by I is impedance, okay? So this Z11 is the driving point impedance at the port 11- with the port 22- open circuit. That is the meaning of this equation. Here the port 2 is open circuited. How we are saying that this port 2 is open circuited? Because I2 equal to 0. And Z is the impedance and 11 is the suffix, so V1 and I1 will come. Okay. So we can say that Z11 is the driving point impedance at the port 11- with the port 22- open circuited. And this parameter is called open circuit input impedance. Okay. Z11 is the open circuit input impedance. Okay. Next, similarly, here now I2 is equal to 0. See, again go to the equation, and here there is another equation. Okay, what will happen when I2 equal to 0? In this case, when I2 equal to 0, then Z21 will become V2 by I1. Okay, so we can write the equation as when I2 equal to 0, that is port 22- is open circuited, then Z21, from the second equation, Z21 equal to V2 by I1. Condition is I2 equal to 0. So we can directly write the equation from the suffix, that is Z21 means Z is the impedance, so we can write V by I. Since it is 2, 1, so upper portion will have 2 and lower portion will have 1. Okay, so Z21 we got that, where Z21 is the, we can say that it is an impedance. Okay, Z21 is the transfer impedance at the port 11- with the port 22- open circuited. So it is also called open circuit forward transfer impedance, since it is connecting the voltage and currents of different ports. So we can say it as a transfer impedance. Here it is input impedance, since it relating the voltage and current of the same port. So its ratio is open circuit impedance. Since this quantity relates voltage and currents of different ports, so we are using the term transfer. Since it represents the impedance, so it is a transfer impedance or open circuit transfer impedance. Similarly, let us see, now we have discussed about the case when I2 equal to 0. Then let us see what will happen when I1 equal to 0. Again go to the equation. When I1 equal to 0, this term will vanish. Okay, this term will become 0. So we will get Z12 will be equal to V1 by I2. Okay. So when first port I11 dash is open circuited, Z12 will become Z12 equal to V1 by I2. So it is the impedance itself, but it is relating the voltage and current of different ports. So we can say that Z12 is the transfer impedance at the port 22 dash with the port 11 dash open circuited. So you can use the term transfer, okay, since it is relating the different ports. And but here the ratio is V by I, so it will give the impedance. So we are using Z12 is the transfer impedance at the port 22 dash with the port 11 dash open circuited. And we can say that it is also called open circuit reverse transfer impedance. Okay. In the previous case it was the open circuit forward transfer impedance. Now you can say that it is the open circuit reverse transfer impedance. Okay. Next, similarly when I1 equal to 0, you can see again go to the equation. When I1 equal to 0, see when I1 is equal to 0, here this term will become 0. Then this term equal to 0 means that you will get an equation V2 equal to Z22 into I2. So you can get the value Z22 will be equal to V2 by I2. So you can write the equation Z22 equal to V2 by I2 at I1 equal to 0. So what is this indicates? This is the impedance itself, and it relates the impedance of the same port. Okay, it relates the voltage and current of the same port. So Z22 is the open circuit driving point impedance at the port 22 dash with the port 11 dash open circuited. Okay, so it is also called open circuit output impedance. In the previous case, V1 by I1 will be equal to open circuit driving point impedance at port 11 dash, and that is called open circuit input impedance. Here Z22 represents the open circuit output impedance. So make the concept clear. Okay, then we can, now we have got different impedance values or open circuit impedance values like driving point input impedance, driving point open circuit output impedance, transfer impedance, that is open circuit reverse transfer impedance and open circuit forward transfer impedance. Like that we have obtained different quantities. Next, in the case of a two-port network, we have to draw the equivalent circuit of the two-port network. So let us go to the equations first, and we are transferring these equations into circuit, equivalent circuit. See here first, now let us draw the equivalent circuit. Here we are taking the equations V1 and V2, and you can see that we are transferring this equation into the circuit form. First we are taking the first equation. In this equation, V1 is obtained by the addition of these two terms. So at the input side, we are marked, first we will mark two ports like this, 11 dash and 22 dash, and then first V1 will be contributed by Z11 I1. So Z11 is the input impedance, so we will draw it in the impedance format, that is we will represent it by a rectangle. So Z11 is there, and I1 is the incoming current to that, so that we are representing I1 like this. Next term is Z12 I2. So Z12 I2 will represents the voltage, you know that, so you can represent it as a dependent voltage source like this. So in the dependent voltage source we will mark Z12 I2 like this. Okay, so this constitutes the input side or input voltage V1 is represented like this. Okay, next we will go to the second port, and where the voltage output voltage is V2, and you can mark the V2 voltage at the output port. Next, here you can see, here Z22 is the, you know that it is the output impedance. Okay, so open circuit output impedance, you can represent this Z22 as a rectangular box. So this is Z22, it is represented by the rectangular box, and I2 is the current flowing to that. So you can represent it like this. And next term is a voltage. Okay, see this is the voltage, so you can represent it by the dependent voltage sources. So it is marked by a dependent voltage source because its value depends upon the current value. So we will mark its value as Z21 I1. So this complete portion represents the equivalent circuit. Now we can do a problem. The problem gives that if the set parameter for the circuit is shown in the figure, find the set parameter for the circuit is shown in the figure. This is the circuit. Here different impedances are ZA, ZB and ZC, and I1 is the current flowing to ZA, I2 is the current flowing to ZC, and V1 and V2 are the input voltages. So we have to find out the values of Z11, Z12, Z21, Z22, etc. So first of all, we know that each of these set parameters are found out by open circuiting the ports. Okay, so first of all, we have to write the equation for the two-port network, that is V1 equal to Z11 I1, Z12 I2, V2 equal to Z21 I1 and Z22 I2. Now we are going. Now first of all, we are open circuiting the second port. That means in the case of open circuit in the second port, I2 will be equal to 0. So this term will be equal to 0 and this term will be equal to 0. So we will get Z11 and Z21 when we are open circuiting second port. Okay. So we can write it when second port is open circuited, we can write Z11 equal to V1 by I1. Okay, that is written here, Z11 equal to V1 by I1. So first of all, we can go to the circuit. So here I2 equal to 0. That means this circuit portion will not be there. So there will be only this circuit. Okay. So current flows, I1 flows in this manner. And in that case, what we need is, we want to find out V1. See, in order to find Z11, we want to find out V1 and I1. Okay. So we have to find out the equation for V1 and substitute in this equation. So here now the current flows in this manner, and this part of the circuit, see, this part of the circuit is not there since I2 equal to 0. So what is the value of V1? V1 will be, by using the Ohm's law, you know that what is V1? V1 equal to current into total resistance. Okay, here total resistance is ZA plus ZB and current is I1. So V1 will be equal to I1 into ZA plus ZB, right? So we can substitute V1 equal to I1 into ZA plus ZB. So Z11 will be equal to, we can substitute the value of V1 here. So we will get I1 into ZA plus ZB divided by I1. So I1 and I1 get cancelled. So we will get Z11 will be equal to ZA plus ZB. Okay. Similarly, when we are open circuit in the second port, I2 will be equal to 0. So we will get this term will be equal to 0. So we will get Z21. Z21 will be equal to V2 by I1. So Z21 is equal to V2 by I1 at I2 equal to 0. So we have to find out the value of V2. So again we can go to the circuit. Here I2 is 0. That means this part is omitted. And we want to find out what value? V2 value. So V2, what is the value of V2? V2 is the voltage across these terminals. Okay. So this voltage, since there is no current, this part will not be there in the circuit. So V2 will be the voltage across the ZB. Okay. Here the voltage across this point A and B dash will be equal to voltage across this ZB. Okay. So what is the value of voltage across ZB? Voltage across ZB you can find out as voltage across ZB is equal to current through the ZB into impedance. Okay, what is the current through the ZB? That is I1. So I1 into ZB gives V2. Okay, so you can write V2 will be equal to I1 into ZB. So you can write Z21 equal to I1 into ZB by I1. I1 and I1 get cancelled. So you will get Z21 will be equal to ZB. So two parameters you have find out. Okay, by open circuit in the second port. Next, you have to find out the other parameters by open circuit in the first port, that is A dash. So when we are open circuiting this A dash, here I1 will be equal to 0. That means when I1 equal to 0, when I1 equal to 0 means there will not be any current flow through this part. So this part of the circuit is omitted and you will have only this part. Okay. So here again you can go to the equation when what will happen when I1 equal to 0. When I1 equal to 0, this term will become 0. Similarly, this term also becomes 0. So you can find V1 equal to Z1 to I2. So Z12 can be found out by V1 by I2. Okay. So you can find that is Similarly, here in the equation when I1 equal to 0, this term will become V2 equal to Z22 into I2. So Z22 will be equal to V2 by I2. So 2 equations you will get when you are open circuiting A dash terminals. So Z22 will be equal to V2 by I2 and Z12 equal to V1 by I2. So you have to, in that equation, see, first we are taking Z22 equation, that is Z22 equal to V2 by I2. In this equation you have to find out V2 value. So you again go to this circuit diagram. See, here this terminal, this current is equal to 0. You want to find out V2. What is the value of V2? V2 is the voltage across BB dash terminals, and it is obtained by applying the Ohm's law. Ohm's law states that voltage will be equal to current into total impedance or total resistance. That is Z2 into ZB plus ZC will be equal to V2. So you can write V2 equal to I2 into ZB plus ZC. So Z22 will become, you can simply substitute the value of V2. So Z22 will become ZB plus ZC. Similarly, we have another equation Z12 equal to V1 by I2 when we are putting I1 equal to 0. So you have to find out V1 in that circuit. So again go to the circuit. V1, what is the value of V1? You know that here I1 equal to 0, that means this impedance will not be there. And when it is not there, V1 will be the voltage across this ZB. So V1 will be equal to ZB into I2. Since current through the ZB equal to I2, so the voltage drop across ZB will be equal to ZB into I2. So you can substitute the value of V1 as in the equation Z12 equal to V1 as I2 into ZB, and in that I2 and I2 will be cancel each other. So you will get Z12 will be equal to ZB. Similarly, in the previous equation you got Z21 equal to ZB. That means Z12 and Z21 are both equal. That means this represents a bilateral network. Okay. So this is, thus we have find out all the 4 open circuit set parameters. Okay. That's all about this problem. Thank you.